Today we're going to talk about the charges of amino acids. How are amino acids charged relative to the physiological pH, which is around 7.3 or 7.4 pH on the pH scale. So we have two types of amino acids. We have polar amino acids and nonpolar amino acids. The nonpolar amino acids are hydrophobic or lipophilic. This means that they are afraid of water or they like fat. So these types of amino acids are found inside the bulk of the peptide chains, not outside, while the polar amino acids are found outside because they are hydrophilic or lipophobic. So they can form bonds with water easily because they are hydrophilic. So the structure of the peptide chain bulks is like that. Let's suppose that it's a circle. On the outside we have the polar amino acids, and on the inside we have the non-polar amino acids. Now for the polar amino acids, we have three types of these polar amino acids. We have polar, but they are uncharged, so they don't have a charge. And we have positively charged, and we have negatively charged. And of course we are talking relative to the physiological pH, the pH of the normal pH fluidity inside the body. So for a pH of 7.3, if the pH of the amino acid that we're talking about is higher than this pH, then it will be relatively basic on the pH scale because it's higher than the pH that we're dealing with. Accordingly, if it's kind of basic, it will keep the H's, the protons, attached. So for the carboxylic group, it will look like that, and the amino group will look like this. On the other hand, if the pH or the pi of the amino acid that we are dealing with is less than the physiological pH, then it will be relatively acidic and it will lose the protons. So the carboxylic group will look like that, and the amino group will look like this. So let's classify the amino acids. Now for the positively charged ones, we will be talking about amino acids with a pi higher than 7.3. So these are lysine, arginine, and histidine. So these are both a 10, have a pi of around 10, and histidine is around 7.58. For the negatively charged ones, we'll be talking about amino acids with a lower pH than 7.3 like glutamine and asparagine. And for the uncharged ones, we have serine, we have threonine, we have tyrosine, cysteine, and asparagine and glutamine. And these ones are uncharged because they have other groups like serine, threonine, tyrosine. They have a hydroxyl group, OH. Cysteine has a thiol group, an SH. Asparagine and glutamine, they have an amide group. So these are the polar amino acids that are found on the surface of the peptide chain molecules or formations. Now we will have an example to show how the pH changes. So let's suppose that we have a peptide chain like this. And we want to calculate the total pH of this peptide chain throughout different pHs, like pH 1, pH 7, and pH 10. So the first thing that we do is that we determine which one is the amino end and which one is the carboxylic end. So this is the amino end, the left side, and this is the carboxylic end. So here we will have the amino group, carboxylic group, amino group, carboxylic group. And this is the free group. The other group is contributing in the bond formation here, so it cannot be used to calculate the pH of the peptide chain. So what we do here is that we will calculate the charge for each amino acid alone, and then we will sum the total to find out the total pH of the peptide chain in a certain or regarding a certain pH value. So let's start with pH 1. For isoleucine, the pH is the isoleucine is a nonpolar, uncharged, and also its pI is around 6. Now the pH is 1, so relatively the pI of isoleucine is more basic, so it will keep all the protons attached. In this case, the amino group will be an NH3+, so we'll have a +1. For lysine, the pI is around 10, so far more than 1. So it will be also kind of basic. It will keep the protons attached, and we will have a 0. A 0 because the carboxylic group, when it has the H, it doesn't have any charges. On the other hand, for the amino group, it's an NH3+. It's written like this because it's an extra proton. Normally the amino group is an NH2. So this is why here it's a +1, here it's a 0. Phenylalanine, also the pH will be higher. The pI will be higher than the pH because phenylalanine is also around 6 of a pI. So we will have a +1 because we are dealing with an amino group. And finally, glutamine. Glutamine has a pI of around 3, still higher than the pH of 1. so we'll have a 0 because we're having a carboxylic end. So +1 gives us a +2. So this is the charge of the peptide chain at a pH 1. At a pH 7, isoleucine, we said that the pI is around 6, so it's less than this. It's less than 7. So at that point, the proton, which is attached to the amino group, will be lost, and we will have 0 charges. For lysine, the pI is 10, still higher than 7. So we will have the protons attached. So here is a 0. Phenylalanine around 6. The pI is less than 7, so the protons will be lost because it will be kind of acidic compared to a pH of 7. So the protons will be lost and donated to the medium. So we will have 0 charges. For glutamine has a pH or a pI of 3. 3 is less than 7, so the proton here attached to the carboxylic group will be lost, and we will have a -1 because the carboxylic group will become a COO negative. So we'll have a -1. So the total charge will be a -1. At a pH 10, same rules apply. For a pI of 6, we'll have a 0 because the 10 is higher than 6. Now for lysine has a pI which is exactly equal to 10. So this would be on the second step of ionization when we talked about the isoelectric point. And because lysine has 2 amino groups and 1 carboxylic group, so it ionizes on 4 steps. And the second step is when the pH equals the pI, and this is when the first proton is lost. The first proton would be rather lost from a carboxylic group than an amino group because it's firmly attached to the amino group, but relatively comparing both groups, it's easier to lose the proton from a carboxylic group. So at that point, when the pH equals the pI of lysine, this proton attached to the carboxylic group will be lost and it will gain a negative charge. Then we have phenylalanine with a pI of around 6, less than 10, so the charge will be 0. And finally, we have glutamine with a pI of around 3, of course much less than 10, so we will have a -1 because the proton here will be lost and the carboxylic group will gain a negative charge. So here, total of -2. And this is how we calculate the charge of a peptide chain throughout different pHs. I hope it was easy for you. And until the next time, I thank you for watching and see you.